Okay, 9.2. Okay, conservation of momentum. And in 9.1, we focus on the definition of the momentum and also the calculation of the momentum. Today, in this 9.2, we will focus on the application of the momentum. This one is the conservation. Conservation, in this case, it means that the momentum will not be changed. But remember it, for the whole system will not be changed. This one similar to the conservation of the energy. Energy cannot be created and cannot be destroyed. Conservation of momentum will be similar case. In this one, the first part, we will focus on the type of collision. Different type of collision, we have different output. Now look at this. The first one will be about the falling to the ground. For example, if we have the object and then let it to drop down to the ground, then what will happen? We have three different cases. The first one, this object will stay on the ground without any rebounds, 反彈, okay, without any rebounds. Then the final velocity of it will be 0. But remember it, in this case, what is the initial velocity? Remember it. During the collision, we will think that just before the collision, we will say that the initial velocity. Just after the collision, we will say that final velocity. Remember it. The initial velocity is not this, okay, not that one. It's just before collision and just after collision. So, in the second case, this object will rebound backward a little bit, okay, for example like that. Then this one just only the example. Just before the collision, the velocity will be v-log, the speed will be v-log. After the collision, the speed will be 0.5 v-log. Then it means that smaller than before. And the last case will be this one. Just before the collision will be v-log, the speed. After the collision, the speed will be v-log. It means that in this case, we haven't any change in speed. It means that even any change in kinetic energy. So, go back to here. In this case, no kinetic energy loss. But in this one, some kinetic energy is lost. But why? Look at this. Initially, we have the GPE, okay, maximum GPE, converted into kinetic energy. So, just before the collision, the kinetic energy will be the greatest. But after it, this object will rebound at a certain height, but this height is not at the same as the initial one. It means that this potential energy will be less than before. It means that after the collision, the kinetic energy is not large enough than before collision. So in this case, we will say that kinetic energy is lost. And how about this? Initially, just before the collision, we have this speed. It means that KE is non-zero. But after the collision, the final speed will be 0. It means that we haven't any kinetic energy. In this case, all the energy will be lost. Okay, lost. But what's the energy? Will be the kinetic energy. Because here we have three different kinds of situation. We will distinguish them into different collisions. Now look at this. Different types of collisions. It means that the last three leads to different changes in kinetic energy. Okay, go back to the slide. This KE lost at all. Some loss, and this one no loss. Then what happened? Look at this. Collisions are categorized into two types. Remember it, we have only two types. What are they? The first one is elastic collision. In some cases, we will say that perfectly elastic collision. In our syllabus, without perfectly, okay, it means that elastic, exactly the same as perfectly elastic. This one is the third level technical terms. Now, in this case, what will happen? Low kinetic energy loss. It means that this one, the total energy after collision will be the same as before collision. How about the loss? Will be 0. Okay, like that. But how about this? The second case. The second case we will say that inelastic collision 非彈性碰撞. This one is elastic collision 彈性碰撞. In this case, in elastic collision, we have energy loss. In this one, the energy loss is not too much, okay, but this one too much. Then this 3, we will say that in elastic collision because we have energy loss. Then next case is this, okay, in elastic collision, a special case, colliding objects stick together, 黐住. Okay, if they stick together, we have two situations. One is it moving together, okay, 黐埋咗一齊行. The other case is they stick together finally at rest. For example, two cars collide each other in opposite direction. Okay, 迎頭相撞. Then finally they will stop, but they will stick together. In this case, we can say that kinetic energy loss will be maximum value. Okay, because the final velocity will be 0. And also this one we will say that perfectly inelastic collision. So next time, just only say that in elastic collision, it means that some energy will be lost. But if we say that perfectly inelastic collision, it means that all Ke will be lost. This one is the part A. Part B, we will focus on the conservation. Once again, what's the conservation? It means that no change. You cannot create, you cannot destroy. But what are they? You should focus on this word, the total momentum of a system. System, it means that inside the system may not be only one object. We will have at least two objects because they should have collision. Okay, one collide with the other. Then this one, in order to have this total momentum of the system is conserved, we have one cases, provided that it means that if no net external force is acting on it, 冇外力出現，碰撞嗰一刻冇外力出現，咁就可以 conserve。有外力就唔得。But in examination, in our cert level, A level, everything, we will not have any net external force during collision. So it means that this statement is always true, okay, especially in examination. But how to do this experiment? To prove it, of course, we have this experiment. This experiment, we have the computer, we have data logger, we have light gauge to measure the velocity of it, and also we have the air trap to reduce the friction wider, and then try to watch the video.
We can use the apparatus shown to determine whether momentum is conserved in a collision. First, measure the mass of each rider. Then, set up the apparatus as shown. A photo gate is placed on each side of the track. The photo gates are used to measure the velocity of the riders before and after a collision. Attach a magnet to each of the riders so that they bounce off sharply in collision. Run the data logger software and choose the interface for photo gate. Enter the length of the cardboard attached on the riders. Then start data recording. Make the riders collide. From the data recorded, calculate the sum of momentum of the riders before and after the collision. Repeat by making riders collide with various initial velocities. In each case, compare the sum of momentum of the riders before the collision with that after the collision. Are the two values always equal? Now replace the magnets on the riders with rubber cushions. One of the cushions has a pin attached, such that the riders stick and move together after collision. Make the riders collide with various initial velocities. Again, calculate the sum of momentum of the riders before and after the collision in each case. Are the two values always equal? We can use the apparatus shown to determine whether momentum is conserved in a collision. First, measure the mass of each rider. Measure the velocity of the
Okay, that's all
We
for
can
this
use
video.
the apparatus.
Okay, you can see that we have two magnets on it. But what is the function of these two magnets? To repel each other. It means that we do not want to have a sound produced during the collision. It means that we want to make the kinetic energy loss in this case will be the minimum value. This one will be the procedure to tell you what will happen. We have the sticky pad and pin. It means that we want to have a stick together cases. Here, why is an air trap used in the experiment? Of course, reduce the friction on the rider. Okay, look at this. Other than it, actually we have the other simulation on it. This one focus on the value. Okay, focus on the collision of it. Because we have the error, so need to get this part. I will show you later. Okay, now go back to here. This one will very important part. Pay attention on it. In examination, especially third level and A level and DSE, this part is very important because maybe one long question will be involved in collision. Okay, look at this. What is the meaning of total momentum? Total momentum, it means that we have momentum, but not only one, maybe two. Depends on number of objects. In this case, we have object A and object B. Then for object A, we will have the initial momentum MAUA. For B, we also have the initial momentum MBUB. Add them together, we will say that total initial momentum. Similarly, for the final one, after the collision, MAVA, MBVB, add them together, will be total final momentum. Then what will happen? We have the equal sign. Equal sign means that before and after, the total momentum should be the same, no change. Then this one we will say that conservation of momentum. But look at this. This table is very important. On your book, put a star on it and remember it. Look at this. Total momentum will be true for all cases. Any cases, including elastic. It means that low kinetic energy loss. Inelastic and also perfectly inelastic. It means that total energy loss or at all. Then you get any type of collision. All of them will be conserved. Total momentum before and after collision should be the same. The total kinetic energy will be the method to distinguish what are they. If total KE no change at all, it means that low kinetic energy loss. Then this collision we will say that elastic. But if all the KE have been lost, then this one we will say that maximum one. We will say that this one is perfectly inelastic. But some of the kinetic energy is lost. Then we will say that elastic collision. Okay. Now here, if this one is perfectly inelastic, then what will happen? Usually will be this one, stuck together after the collision, common velocity. Okay, in this case, kinetic energy loss will be the maximum one. Okay, once again remember it. Perfectly inelastic case, usually they will stick together, will have the common velocity. Okay, this one is the application. You can try to watch the video. This one is a Newton candle. I think some of you have watched it before, or you have this talk.
This is a Newton's cradle. We can use it to demonstrate the conservation of momentum. Try to release a ball in the Newton's cradle from a certain height. What do you observe? Now, repeat by releasing 2, 3 and 4 balls respectively. What do you observe in each case? This is a Newton's cradle.
Okay, what can you see? Can you see that
the ball in the Newton's cradle from a
can you see it? One in, one out.
Certain height. What do you observe? Now, repeat by releasing 2.
Okay, now what happened? We have 2. This 2 will have the initial total momentum. Once again, this experiment to show you that conservation of momentum. So 2, okay, 2 of them come into the system. Then
3 and 4 balls respectively.
2 out, 2 in, 2
What
out.
do you observe in each case?
Now 3 in, 3 out. Last one, 4 in, 4 out. Okay. Next case, next experiment. This one you know it before in the last chapter. Vesicule collision. Actually, this one is a perfectly inelastic collision. Once again, this one is perfectly inelastic collision. If this one is elastic collision, what will happen? Then this man will jump down and then absorb the energy, push it back to the original height. If this one is perfectly inelastic collision, because if this one is perfectly elastic collision, no energy loss, no kinetic energy loss, then this one will be bound backward to the certain height, initial height, and then forever. Okay, so now this one we want to have the perfectly inelastic collision. It means that this man will stick on the air cushion and stop it, of course, finally. And next one is the catching a cushion. It means that this a perfectly inelastic collision. Okay, you get the cushion. You send or fold this cushion to him, and then this boy, or this man catch it. Then what will happen? They will stick together. This collision we will say that perfectly inelastic collision. 等於翻大家接住個波一齊向後吞，就係一個 perfectly inelastic collision 啦。So look at this question. Which type of collision are they? Okay. Look at this. Sticks to the ground. It means that all the energy will be lost. This one should be perfectly inelastic. And this one will rebound back to the original height, low energy loss. This one should be perfectly elastic collision. This one should be inelastic collision. Okay? This part is very important, especially the table. I stop here.